Nope, it's not working yet. Now it's working. Okay, guys, today it is 3/26/19. So what we're going to do today is we're going to find points of intersections between parabolas and lines, okay? So we're going to find points of intersections between parabolas and lines, okay? So first of all, number one, okay? So it says graph. Well, let me see if I can go ahead and do this. Y equals. You guys have a calculator? Okay, y equals. And I'm going to just put in the first one, x squared plus 5x plus 6, okay? Here's my first one. And if I go ahead and graph that, okay, looks like it's about that. Looks like it goes through -2 and -3, and it comes down. It looks like it goes something like this, okay? 1, 2, 3, 4, 5, 6, okay? Okay. Okay, that's what I have on my calculator, okay? I'll show it again. There it is. There it is on my calculator. You guys see that? There's my equation, and there's my graph, okay? And I know it goes through -2, -3 because I could factor this. I really could. If I wanted to get fancy, I could factor this one into x plus 2, x plus 3, and then I know many equations, my zeros are at -2 and -3. Okay, one more time, right? This parabola will factor x plus 2, x plus 3. So I know my zeros are definitely at -2 and -3. Okay, and then I just let my calculator do the work. Okay. Okay. Now I want to also do the line. So I go y equals. I want to do a second. I'm going to do my second equation. So I've got my second y. Got y2, right? Second equation. So my second equation is going to be a -x plus 1. Okay. And I'm going to graph that. Okay. Okay. There it goes. Now it's kind of hard to tell exactly where it intersects, but it looks like it's at -1 and about maybe -2. So it looks like it's right about there. And the other one is kind of hard to tell, but again it looks like maybe 1, 2, 3, 4, 5.
How would you find it on the calculator if you were to work it on a table?
6. Great question. And maybe 6. Now, how accurate am I? Well, I can also graph some of this by hand. I do know how to graph. I'm going to show that I am. -x plus 1 starts at a positive 1, right? Down 1, over 1, down 1, over 1. Actually, I missed it, didn't I? It's right there. Okay, so there's my two lines. Let me put one in one color and the other. Okay, here's my line, and there's my parabola. Okay, now if you guys would stop talking, I'll explain what I did. Okay, so I got the parabola from graphing it. Y equals x squared plus 5x plus 6. Okay, if I graph that, hold on, let me go back. If I graph just the parabola, it looks like this. Now, a few things I know about parabolas. I knew its zeros were at -2, -3, and I could do the 1, 1, 2, 4, but it looks something like this, okay? Second thing I know is I do know how to graph a line. I really do. I know how to graph this line. Start at 1 on the y-axis, right? And then I'm going to go slope of -1 over 1, down 1 over 1, down 1 over 1. So I get a straight line. And it seems to be as if the two intersect here and here. Okay, so I think the answer is at 1, 2, 3, 4, -4. 1, 2, 3, 4, 5. I think one point of intersection is right there at -4, 5. And I think the other point of intersection is here at -1, 2. Okay, I think those are the answers. And that would be the answer to the system. To find out where they intersect, my answer is boom, right there, the 2 points. Okay, the 2 points. So now, Isaac asked, okay, Mr. Davies, how do I get that from the calculator? And I'll show that too, okay? So y equals, I put in the other one, okay? And it's a -x. plus 1. Okay. Now, if you absolutely hate factoring, you absolutely hate the math, but you can push buttons, I'm going to show you a nice little trick. Okay. So you could come into this test on Friday and just push the buttons and get the answer. You like that idea?
Yeah.
Okay. Now, my famous book, my famous button's right there. I like that calculate, right? I like that. So let's go to calculate. Okay, so we're going to second calculate. And it has this intersect thing, right? See this intersect? Let's go to second calculate. It says intersect. Well, that's what I want to do is find out where they intersect, right? So I'm going to push enter. It says first curve. So let's get the point over close to our point, okay? So first curve, just move the cursor over. Use the back and forth buttons. Don't use the up and down buttons, use the back and forth buttons, okay? So I'm moving it over, over, over. So right about there, you guys, intersects right about there. Blinking. I'm going to let you catch up. Oh, you got the wrong one.
I know.
You're heading. Okay.
I'm
Blinking,
down.
blinking, blinking. So I hit enter. Now, second curve. Now you push the cursor. Okay, here's my, I'm going to get it. So, but I don't want it there. Don't want it there. Where do I want it? Right about where they intersect, right? Does that make sense? Right about there. Blinking, blinking, enter. Guess, I'm going to guess. And guess what? Negative 5, 6. Negative 5, 6. I am way off. I thought it was negative 4, 5.
No, wrong.
I was wrong. Guess what? It's at negative 5, 6. So guessing, it's not very good. It's not a good idea, is it? Okay. Now let's check my other one. Okay. Second, calculate. Intersect. Right. First curve. I want to go over to this one. Right. So I get my cursor here. It's right about there. Okay. It's right about where they intersect. Right. Blink, blink, blink. Enter. Second curve. Well, I don't want it there. I want it right about where they intersect. Right about there. Right. Enter. Hold on. Negative 1, 2. Now that one I got right. That one I guessed right, okay? Negative 1, 2. Yeah, Derek? Oh my gosh. Yes, I'll let you teach. You're totally correct. Okay, now, that's kind of a pain. To me, that's rather tedious. I had to get my calculator. I had to graph the curves. I had to use the intersect button. It works, so it works. However, I like Derek's idea better. Because can it be solved by algebra? Yes, it's going to be faster and more accurate. I don't have to graph or anything. So can it be done by algebra? Yes. Watch this. So let's take our y equals x squared plus 5x plus 6 and our y equals negative x plus 1. Okay? All right, got it? Well, we're going to do a substitution. Let's use a little bit of common sense. This x squared plus 5x plus 6 equals y, right? And this negative x plus 1 equals y. So they should equal each other. Does that make sense? They both equal y, so they should equal each other. That just makes sense, guys. Does that make sense? So let's set them equal to each other. So I'm going to go, okay, x squared plus 5x plus 6 equals negative x plus 1. Right, Derek? That's what you wanted to do, correct? Now I think this is faster. No graphing, no calculator, just algebra. Okay, so let's solve. So I'm probably going to need to factor, but before I factor, I need to set it equal to 0. Okay, so let's bring everything over here. Let's bring things this way. So to do that, I'm going to go plus x, because that's going to bring the x over, right? And I'm going to go minus 1, because that brings that over. So what's left over on the other side is 0. Good. To find the zeros, I got to make it do 0. So I'll have an x squared plus a 6x plus 5 equals 0. Okay? Now it's very factorable. 5 and 1, right? You guys agree with 5 and 1? So I can factor it, parentheses, x plus 5, x plus 1 equals 0, right? Mini equations, x equals negative 5. And x equals negative 1. Okay, now we're only halfway, but at least we're at an easy halfway, okay? Because that's x and x. We don't have any y's. It's x and x, right? Yeah, plug it in. So one of my answers is going to be negative 5 something, right? One of my answers is going to be negative 5 something. So let's take the 5. So you can plug it into either equation. Well, personally, I think this one looks easier. You guys agree that one looks easier? Either equation, plug it in here for x or here. Both work. Both work. Let's choose the easy one. Okay, so I'm going to take and put my -5 right there. Okay, so I'll have a y equals a -5 plus 1, because I put my -5 right there. To my -5, put it right there. -5 is a 5 plus 1, which is 6. So one of my points is -5, 6. I have 2 points, right? I've got 2 points. The other point is a -1 something, right? Something. And again, I can put the -1 either into the first equation or the second. The second is much easier. You guys agree? The second one. So I'm going to rewrite this as a y equals a -1 plus 1, or 1 plus 1. 1 plus 1 is 2. So I have a 2. Now let's go back. Okay, let's go back to what we just did. All right. Let's summarize. So I had an opportunity to do this problem by graphing. I'm pretty good, but I missed it, didn't I? Dang it. I'm pretty good, but I missed it. I actually had it wrong. It wasn't -4, 5. It was really a -5, 6, right? I used the calculator, and the calculator gave me the answer by intersect, which worked. It was great. It was awesome. As long as I know how to use the calculator, that'll work also, right? A little tedious for me, too many button pushings, but it worked, okay? Have to have the right window. But for me personally, being a math guy, I like the math, because the math worked really well for me, and I got the exact answer. Okay, let's turn the page. Okay. All right. So, example number 2. Solve this system by algebra. All right. So, I'm going to do it by algebra. I'm going to go x squared plus 1 equals x minus 3. Okay. Since x squared plus 1 equals y, and x minus 3 equals y, since they both, hold on, you guys can't see that, my bad. Okay, since they both equal y, then why not set them equal to each other? Does that make sense? They both equal y, therefore they should both be equal. First equation equals y, second equation equals y, so both equations are equal to each other, okay? Just makes sense, right? Logic? So, okay, let's go minus x, plus 3, I've got a x squared minus x plus 4 equals 0, okay? Now, we got two things, two methods. One, we could factor, but it doesn't factor. It won't factor. So let's use the quadratic formula. Now at this point I'm thinking, I don't want the quadratic formula, so now I might use the calculator, okay? But let me show you the quadratic formula, and then we'll look at the graph. Okay, I want to do both. Okay, quadratic formula from here. Okay, quad formula from here. My A is 1. Here's my A. Here's my B. And here's my C, okay? All right, so I'm going to go ahead and go negative B plus or minus square root of B squared minus 4 times A times C all over 2A. Now, right now, I already know I can stop. How do I know I can already stop? I can stop. Okay, I'll go one more step further, and you guys will agree. 1 plus minus square root of 1 minus 16 over 2. Okay, tell me why can I stop?
You're going to get 9.
So, I'm going to get a negative, right? I'm going to get an I. I'm going to get an imaginary. Can you have an imaginary point on a graph?
Nope.
So what's going on graphically? So there's no answer, right?
Yeah, there is no answer. That's what happens on the calculator.
So let's check it. Let's see what's going on. So if there's no answer, thank you, Isaac. Isaac already put it in, and it looks like this.
No.
So it's kind of cool because you can see it. They don't intersect, do they?
No.
And you know mathematically it proves they don't intersect, right?
So what would you just put on the
So
test?
we
No
just
answer.
write
No answer.
if we got that right.
Right, no answer or no intersection. No intersection is the best. Or no points in common, no points in common, no intersection, no answer. Thumbs up?
Mm-hmm.
Okay, last one, example 3, by algebra. So let's do this one, okay? So I'm going to say x squared plus 5x plus 6 equals negative x plus 1, okay?
We just did that.
Okay, did we just do this one?
Yeah, we did on the front.
The exact same one. We don't need to do it. How do you like that? Okay, So let's look at page 146 real quickly, and that wasn't a hard lesson, was it? No.
Not as a factor.